Okay, so when you're finding more than one angle, you're going to have to use more than one property to find your missing angles. The easiest angle to find would be angle B, because angle B and the 25-degree angle are vertically opposite. So I'm going to go ahead and write the value for angle B, that's 25 degrees. Okay, vertically opposite angles are equal. So we can say that B is equal to 25 degrees. Now, we have more than one option to find the other two missing angles, which are angles A and C. We don't have to use the angles at a point property. We could also use the supplementary angles property as well. But both of those properties will work to get you the values for angle A and angle C. Okay, the easier method to use, however, would be the supplementary angles property. Now you can see that angles, I'm just going to highlight where the line is. You can see that angle B and angle A are on the same line. So what I'm going to do, I'm going to use the supplementary angles property. So I'm going to say angle A and B are supplementary because they're on the same line and they are adjacent. So that means they are supplementary, and supplementary angles add up to 180 degrees. Okay, so we found our value for angle B. So to get the value for angle A, if angle A and B add up to 180 degrees, to find angle A, I would just subtract the value for angle B, which is 25 degrees, minus 180 degrees minus 25 degrees, and that would give you 155 degrees. Okay, you should also notice that to find angle C, angle A and C are vertically opposite. I forgot to state my reason up here. Angle B and the 25-degree angle are vertically opposite angles. And vertically opposite angles are equal. Okay, so angle A and C are vertically opposite as well. And as we said before, you can look for the shape of an X to tell you whether or not two angles are vertically opposite. Angles A and C are vertically opposite angles, so angle C is equal to the same measurement, which is 155 degrees. Okay, the next example, you see where we have two angles that are inside a right angle. And how do we know that it is a right angle? Your right angle has a small square at the vertex of the angle. Okay, so don't just look at the picture and assume that an angle is a right angle. You have to look to see whether or not it has a square at the vertex. Otherwise, you cannot safely say that it is a right angle. So seeing that there is a small square at the vertex, we know that this is definitely a right angle. Now, these are what we call complementary angles because complementary angles add up to 90 degrees or add up to a right angle. So to find angle X, I'm just going to subtract the 37-degree angle from 90 degrees. And that would give you 53 degrees for X. Okay, so now that we're finished reviewing our angle properties, the relationship between angles formed on intersecting lines, we're going to go over algebraic expressions. So an algebraic expression is any number, variable, or different operations combined together, while an equation is two different algebraic expressions combined. Now, the difference between your algebraic expression and algebraic equation is that one of them has an equal sign, the other does not have an equal sign. Algebraic expressions don't have an equal sign, while equations have an equal sign. Both of them have numbers, variables, and different operations. So that is what they have in common. However, remember that expressions have no equal sign, so you'll notice that in this example, there's no equal sign there, while equations have an equal sign. Okay, so these are the different parts of your algebraic expression. It's the same for algebraic equations as well, but we're just focusing on expressions now. Okay, so the coefficients, as we said before, are the numbers that are in front of the variable. Now, your coefficient is the number that is being multiplied by the variable. Your constants now are the numbers by themselves. So remember the difference between coefficients and constants. The variables are just the letters in your algebraic expression. So x and y would be the variables for this expression. The terms are all of the different numbers, variables, and operations in your expression. So 3x, 5y, and 9 would be the terms in this algebraic expression. Okay, so how do we simplify algebraic expressions? Expressions are put into their simplest form so as not to be confusing or too complex. Okay, so say for example we have this expression with 4 terms. We can actually reduce this algebraic with 4 terms into an algebraic expression with 2 terms. One way of simplifying expressions is to combine like terms. Now let's talk about what like terms are. Like terms are terms with the same variable and the same power. For example, if you have 2x and 4x, those are examples of like terms. Also, 5 and 6 are examples of like terms as well. Constants are like terms to other constants. So remember, like terms are the ones that can be combined. If they're not like terms, you cannot combine them. Now we're going to explain what do we mean when we say combine like terms. Alright, so for example, going back to this expression, we can see that 3x and 7x are like terms. They have the same variable, which would be x, and the same power. Now, whenever there is no power, you can put a power of 1. Also, when there is no coefficient in front of a variable, you can also put a coefficient of 1. Because any number raised to the first power is still the same number. Any number multiplied by 1, so remember the coefficient is being multiplied by the variable. So if we put a coefficient of 1, we're multiplying that variable by 1, and we would still get the same variable. That is why putting a coefficient of 1 in front of a variable does not change the variable. Or putting a power of 1 on a variable does not change the variable either. Okay, so 3x and 7x are like terms, and the constant terms can be combined as well. So 6 and 3 can be combined. So this is what we mean by combine our like terms. So these are the steps for simplifying our algebraic expressions. First, we're going to group the like terms. That means we're going to rewrite the expression with all of the like terms beside each other. Then remember to keep the same sign that is in front of your term. So the sign that is in front of the term is very important as well. Now we're going to combine the like terms. This is how you combine like terms. We're either going to add or subtract their coefficients. Now keep in mind that we're only going to add or subtract the coefficients, but we do not do anything to the variable. So the answer must have the same variable. If your variable has a power, your answer must have the same variable and the same power. Okay, the last step is to write the simplified expression. Now this expression should be shorter than the original expression. So going back to this example, we are going to simplify an expression like this. For example, this expression has 4 terms. Our final answer must have 2 terms. It must be shorter than the original. So if you're simplifying an expression and it is not shorter than the original, or it's longer than the original, then something is wrong. Okay, let us start with these examples. So it says group the like terms to simplify the expressions below. So it's not asking us to combine the like terms as yet. It's just asking us to group them. So we're going to group them by writing all of the like terms together in the expression. Now keep in mind that we're not going to change anything as yet. We're only collecting or grouping the like terms. Okay, so the like terms, as we said, are the terms that have the same variable raised to the same power. Okay, so you'll see that 2m and 4m have the same variable. So we're going to just write those beside each other. Now keep in mind that I keep the same sign that was in front of 4m, I put it back in the expression when I'm rewriting my term. Okay, the next pair of like terms would be 5n and 3n. So I'm going to rewrite those two terms keeping the same sign. There was a plus sign in front of this 5n. I write the plus sign when I am rewriting the expression. Same thing for the 3n. There was a plus sign in front of this 3n, so I put that back in my expression. Okay, next example, we have 6u plus 9v plus u plus 3v. Okay, so the like terms in this case would be, I can see that 6u and u have the same variable, so I'm going to write those beside each other. Then we have 9v and 3v. I'm going to write those beside each other as well. And remember, you always put the same variable, the same sign in front of your term when you're rewriting your term. Okay, I want you to pause the video and I want you to try grouping the like terms that are in question C, D, and E. Okay, once you've done question C, you'll notice that A and A are like terms, so I'm going to write those beside each other. And the order in which you write the terms does not matter. The most important part is getting the signs, is putting back the same sign that you had in front of that term. That's the most important part. And it is ensuring that you group all of the terms that have the same variable and the same power. So it doesn't matter what order you write them in, so as long as the sign is the same that is in front of the term, and so as long as the like terms are put beside each other. So plus 2b minus b. So you notice that I did not put a plus sign here because there was originally a minus sign in front of this term, which is b. So it's going to be 2b minus b. For question D, all right, let me see if I can create a little more space. Okay, for question D, you'll see that 5a and 5a are like terms. Also, the coefficients don't matter in this case. The coefficients can be different, but in order for them to be like terms, they have to have the same variable. That is what is most important. The same variable and the same power. Okay, so 5a and 5a are like terms, and you notice that I put the minus sign in front of this 5a when I'm rewriting my expression. And I am going to write 2b and 6b beside each other because those two are like terms. Okay, question E now. You will see that, let me try to copy it and put it here. Okay, for question E, the like terms are going to be 9p and 2p. Notice that I put the minus sign in front of this 2p. Then we have 3q. Notice that I put a plus sign in front of the 3q minus 3q. Okay, so as long as the signs are the correct signs, so as long as the variable and the powers are the same, then you have successfully collected your like terms. Now we're going to look at how we simplify these algebraic expressions. So the only thing we have done so far is collect the like terms. So what I'm going to do, since since collecting the like terms is step 1, I'm going to move on to step 2. I'm going to need these to do step 2. So I'm just going to duplicate this slide. Okay, let us create a little more space. Okay, so the first step in simplifying your algebraic expressions is to group or collect your like terms. So we're going to need these for completing step 2. Okay, so for question A, we already grouped the like terms. We already completed step 1. So we're going to move on to step 2, which is to combine the like terms. Alright, so to combine the like terms, we are only going to add their coefficients, either add or subtract, depending on what side is between your two like terms. Okay, so between these two like terms, there's a plus sign. So that means we are going to add. Okay, remember, once you add your coefficients, you're going to write the same variable and the same power, if there's any power. So this is going to become 2 plus 4m. That gives us 6m. Then we have the other pair of like terms that would be 5n and 3n. So what we're going to do, since there's a plus sign between these two terms, that means we are going to add their coefficients. And that would give us 5 plus 3n would give us 8n. Remember, we only add the coefficients and keep the same variable. Or if there's any power, you're going to write the same power. So say, for example, this was 5n squared plus 3n squared. Our answer would have been 8n squared. Okay, this is our final answer. So you'll notice that our original expression had 4 terms. Our final answer only has 2 terms. So that means we have successfully simplified our algebraic expression. So our answer is 6m plus 8n. Now we're going to be doing the same thing for question B. We have already done step 1. We're going to move on to step 2, which is to combine the like terms. So 6u plus u. Remember, I said earlier that whenever there is no coefficient in front of a variable, you can put a coefficient of 1. So I'm going to write 6 plus 1. Then we're going to keep the same variable, that's u. There's also a plus sign between 6v and 3v, so that means we have to add their coefficient. And that would give us 7u plus 12v. And that's our final answer. Okay, keep in mind that I put the plus sign that is between the two pairs of like terms as well. So there was a plus sign here, and I rewrote the plus sign that is between the two pairs of like terms. For question C, we are going to start combining our like terms. You'll notice that we have a plus a. Remember, whenever there is no coefficient, we can put a coefficient of 1. So it is like you're adding 1a plus 1a. So it's going to be 1 plus 1. We're adding their coefficients. Plus, now we have a minus sign between this pair of like terms. That means we're going to be subtracting. And since there's no coefficient in front of this term, I'm going to put a coefficient of 1. Then we're going to go ahead and subtract their coefficients and keep the same variable. So that becomes 2 minus 1b. We're going to get 2a plus 2 minus 1 is 1, so we get 1b. Or you can write just b. Okay, so 5a minus 5a. any number that is subtracted from itself is going to give you 0. Same thing for terms. Any term that is subtracted from itself is going to give you 0. So I'm going to put 0 here. Then we have 2b plus 6b. Notice that there is a plus sign here, so I'm rewriting the plus sign. Now we're going to move on to adding this pair of like terms. And since there's a plus sign between the two terms, that means we have to add their coefficients and write the same variable. So it's 0 plus 2 plus 6 is 8, 8b. And that's our final answer. So 0 plus any number is itself. So a neater way to write it is to say, so I'm going to change this to, so we would get 8b here, but a neater way to write it is to just add the 8b to 0. Any number added to 0 is itself. So the neater way to write this answer is to just write 8b. Okay, last question here. We have 9p minus 2p. The sign between these two terms is a minus sign. That means we are going to be subtracting their coefficients. And we write the same variable. Now there's a plus sign that comes after this pair of like terms, so I'm rewriting that plus sign. Then we have 3q minus 3q. As I said before, any number that is subtracted from itself is 0. Same thing for terms. Any term that is subtracted from itself is going to give you 0. Okay, so 9 minus 2 is going to give us 7. That's 7p plus 0. And the neater way to write it, this answer is still correct. If you left it like this, it would still be correct. But a neater way to write it is to just write 7p. Alright, that's basically it for simplifying algebraic expressions. And I want you to use the steps that are here if you're not sure what to do when you're given an algebraic expression to simplify.